So here's an example of finding critical points of a function. Suppose we have the function y equals x cubed minus 9x, and the graph is shown here. We notice that the function has a relative maximum between -3 and 0, and then a relative minimum between 0 and +3. And we'd like to know the location of those points. So what we're going to do is take a derivative of the function. So y prime equals 3x squared minus 9. And this is the derivative, and of course it's a critical point either where this doesn't exist or where this equals 0. Well, it's a nice polynomial, so it always exists, so that's not a problem, but we can set it equal to 0. If we set it equal to 0, we get 3x squared equals 9, x squared equals 3, and x equals plus or minus the square root of 3. Those are the two critical points of the function. So the only max or min that the function possibly could have would be at those 2 points. And conveniently, we see this appears to be exactly where the max and the min are. So of course this minimum is the positive number, so that appears to be at a coordinate of x equals positive square root of 3. And then the relative maximum, that's at a negative coordinate, that appears to be at a coordinate of x equals negative square root of 3. So here we'll just be satisfied looking at the graph and matching up the critical points to what it looks like on the graph. But in future videos, we actually will talk about how to determine, even without the graph, how to determine whether a critical point is a max or a min.